All right, let's jump right into this explainer. I want you to do a quick mental exercise with me. Go ahead and stretch your arms out as far as you possibly can. Seriously, stretch them out. Because from the very tip of your right middle finger, all the way across your body to your left, we are going to map out the entire 4.5 billion year history of planet Earth. It is an absolutely incredible way to put deep time into a human perspective, and it really puts our tiny place in the universe into scale. Here's the crazy part. Your entire right arm, it's just this completely uninhabitable hellscape of molten lava. You literally have to travel all the way across your torso just to get to microscopic slime. Animals don't even show up until your left wrist. And all of recorded human civilization, the whole shebang, it fits entirely on the very tip of your left middle fingernail. Earth is unimaginably old, and we humans are just the newest kids on the block. To see how we get to that tiny fingernail, we gotta rewind to the very tip of your right hand. Picture this. About 4.5 billion years ago, our sun's lights came on. It's wild to think about, but Earth at this point was just a planetesimal. Basically, a clump of rock and heavy metal pulled together by gravity that just wasn't fully baked yet. It quickly turned into this glowing sphere of magma. And then, a massive Mars-sized planet named Theia slammed right into it. The impact was so colossal, it blasted a huge ball of magma into orbit, which eventually cooled down to become our moon. Moving slightly down the arm, things are starting to cool off from that violent, chaotic beginning. That early magma ball was getting absolutely hammered by asteroids and comets. But those comets were special because they were actually delivering precious water to the surface. Eventually, the planet began cooling off enough to form a solid rocky crust. And when the surface temperature finally dropped below the boiling point, right around 4 billion years ago, that delivered water condensed to form Earth's very first oceans. Now, down in the depths of those brand new oceans, something truly wild is happening. Around 4 billion years ago, deep underwater, near these incredibly hot hydrothermal vents, the conditions for life began to brew. These vents were basically nature's chemistry labs. They provided the perfect energy source and pumped out the exact 6 crucial elements needed to kickstart life. We're talking carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. You know, we often think of life as this sudden, magical cosmic spark. But actually, it was a highly complex, yet totally unstoppable 4-step chemical reaction. The vents released the minerals, which reacted with local ingredients to form the precursors of amino acids. And ultimately, this created self-replicating RNA biomolecules. Once a biomolecule figured out how to literally make more of itself, that chemistry just couldn't be stopped. Right around your right bicep on our timeline, this self-replicating chemical chain reaction hits a massive milestone. We get LUCA. That stands for the last universal common ancestor. This microscopic single-celled organism is quite literally the great-grandparent of every single living thing on this planet today. Every shark in the ocean, every cactus in the desert, and yes, you and me, we all connect back to this exact piece of microscopic sea slime. But hey, while early life was busy figuring itself out, the Earth's plumbing was going absolutely crazy. Around 2.7 billion years ago, extreme interior heat injected space-delivered gold, which was brought in by those earlier asteroids, deep into the oceanic crust. Eventually, volcanic activity forced those precious minerals closer to the surface, which creates a fascinating puzzle for geologists today, right? How do we actually locate those ancient hidden veins of gold? To figure that out, let's look at a pretty amazing case study of modern, high-tech treasure hunting with a team called Nevada King. Over at their Atlanta Gold Mine project, they have already defined over 1 million ounces of high-grade oxide gold. This specific type of oxide gold is a massive deal because millions of years of time and geology have basically done the hard work for us, freeing the gold from the larger rock crystals. That makes it significantly easier and cheaper to process today. This is just a brilliant example of how modern tech is basically rewriting geological history. I mean, instead of staring at one tiny traditional spot on a map, teams zoom out. Nevada King analyzed an entire 7-kilometer collapsed supervolcano. By layering in AI, drones, and advanced geophysics, they pinpointed deposits that had been hidden for 30 million years. By drilling just 350 meters from historical sites, they hit massive oxide gold right at the surface. It proves that understanding Earth's deep, chaotic history can be incredibly lucrative. Okay, jumping back to our biological timeline, we're at your right shoulder now. LUCA's descendants, known as cyanobacteria, are practically taking over the oceans. And about 2.7 billion years ago, they did something completely revolutionary. They literally invented photosynthesis. They started taking carbon dioxide and just churning out oxygen. But here is the incredible irony of this situation. This massive biological upgrade, it almost sterilized the entire planet. Pumping all that new oxygen into a methane-rich atmosphere triggered early Earth's very first mass extinction, known as the Great Oxidation Event. Why? Because to the original anaerobic microbes that dominated the world back then, oxygen was highly toxic. It wiped almost everything out. And it gets worse. Losing all that greenhouse methane actually plunged the Earth into a massive snowball ice age. The planet was literally frozen over for hundreds of millions of years. It was only interrupted about 2 billion years ago when an absolute monster of an asteroid, 20 kilometers wide, which is double the size of the one that killed the dinosaurs, smashed into South Africa. The Vredefort impact folded the Earth's crust, buried another massive goldfield, and released enough carbon dioxide to finally thaw out our frozen planet. Now, as we move down your left arm, life decides it's time for a serious upgrade. Single cells began to literally swallow other single cells, turning them into internal powerhouses. This microbial mingling evolved simple bacteria, which you can kind of think of as a messy studio apartment where everything just floats together, into complex eukaryotes. Think of eukaryotes like luxury mansions with specialized rooms, organelles, and a nucleus. If you're a complex, multicellular creature today, you entirely owe your existence to this architectural cellular upgrade. While the cells were busy remodeling, the Earth's landmasses were playing a billion-year game of bumper cars. The continents smashed together and broke apart into these massive supercontinents. First, there was Colombia, whose barren rocks were just blasted by UV radiation because we didn't have an ozone layer yet. Then came Sardinia, which blocked warm ocean currents and caused another ice age. And of course, that all leads up to the famous Pangea. All right, we finally reached your left wrist. About 530 million years ago, life absolutely exploded. After billions of years of basically just being sea slime, a sudden spike in ocean calcium allowed organisms to grow hard parts. This kicked off the Cambrian explosion, a rapid, vicious evolutionary arms race. I mean, if one creature grew a shell, the next one grew teeth to crack it. To defend against teeth, the next one grew heavy armor. The shallow seas became this incredibly fast-paced marine war zone. But right in the middle of your left forearm, geology strikes back. The supercontinent Gondwana drifted directly over the South Pole, and that triggered a massive global freeze. Sea levels drastically dropped, draining the shallow coastal waters where almost all this new complex life lived. This event, known as the Ordovician extinction, ruthlessly wiped out a staggering 85% of all species on Earth. When the ice finally melted, life bounced back. But man, the oceans were a terrifying place to live, completely filled with giant armored fish. Around 375 million years ago, creatures like Tiktaalik literally dragged themselves out of the water. As one paleontologist perfectly put it, to a fish, going on land wasn't an adventure to the unknown. It was a refuge from the giant armored predators. Heading onto dry land was a desperate move just to avoid being eaten. And when they escaped onto land, they walked straight into Earth's very first true forests. Now we're at the base of your left hand, roughly 252 million years ago. And the planet undergoes a near-total reboot called the Great Dying. Massive volcanic eruptions pumped carbon dioxide into the atmosphere for 1 million years, turning the oceans entirely acidic. It was unbelievably deadly. 96% of all marine species and 70% of land animals just vanished. It is the absolute closest complex life on Earth has ever come to total annihilation. But you know what they say? Life always finds a way, right? When the supercontinent Pangea finally cracked apart around 175 million years ago, it shifted the global climate dramatically. The world became this steaming, lush, tropical paradise. With absolutely zero polar ice caps, sea levels were nearly 200 meters higher than they are today. It was the ultimate all-you-can-eat buffet for the dinosaurs, allowing those herbivores to grow to the size of 4-story animal skyscrapers. So those gigantic reptilian animal skyscrapers completely ruled the Earth. That is, until about 66 million years ago. Their rule came to a screeching, fiery halt when a 10-kilometer-wide asteroid zeroed right in on the Yucatan Peninsula. Literally, in a flash, 160 million years of dinosaur dominance ended in one earth-shattering boom. This single cosmic impact essentially triggered a global nuclear winter. The immediate devastation, combined with the freezing darkness that followed, wiped out 75% of all species on the planet. The environment became so completely hostile and food became so incredibly scarce that no land animal larger than 25 kilograms, which is roughly the size of a medium dog, could survive the fallout. But here's the silver lining. With the giant dinos out of the picture, our crafty little shrew-like mammalian ancestors finally had their shot. They rushed out to fill every single ecological niche left empty. It is just mind-blowing to think that over tens of millions of years, those tiny survivors rapidly evolved into bats, giant herbivores, and even whales. Eventually, early hominids started walking upright on two legs, and about 800,000 years ago, our ancestors figured out how to control fire, which really set the stage for human dominance. And that brings us, finally, to the very tip of your left middle fingernail. Just 5,500 years ago, that's when human civilization as we know it began. After 4.5 billion years of magma oceans, ice ages, asteroid strikes, and brutal mass extinctions, an organism finally evolved with the ability to read, write, and ask incredibly complex questions about this whole wild ride. We have literally seen it all, from unbreathable, toxic skies and totally frozen snowball planets to crust-shattering volcanoes and world-ending asteroids. Earth is this incredibly dynamic, beautiful, yet undeniably violent engine of creation. So I want to leave you with one final provocative thought today. Considering this endless cycle of catastrophe and biological rebirth that we've just mapped out together across your arm span, what unimaginable shifts await us in the next arm span of time?